All right, so for this example, we want to determine if this set of functions is linearly independent or dependent. And if you think about the fact that it's three linear functions, your intuition should hopefully tell you that this is going to be a linearly dependent set of functions. Because again, two lines would cross at a point, but if you think about a third line, that could probably cross and coincide with others. And you could definitely generate a third line with combinations of two other lines. But again, let's not get into that right now. Let's just kind of think about how we're going to approach this. So the absolute easiest way to approach this would be looking at the Wronskian, because the Wronskian for this is really, really simple. The Wronskian, again, is a 3x3 determinant, which has the original functions for the top row. It has their first derivative for the second row, and then their second derivative for the third row. It should be pretty obvious to us that if we were to take this determinant, it would just equal 0 for all values of x, because anytime you have a row of zeros, it just wipes out the entire determinant. And you can learn more about this if you Google determinants and 0 in linear algebra. So again, because it's equal to 0, we know it's going to be linearly dependent. Another way to do this would be to go ahead and form a linear combination, which would be C1 times 2x plus 1 plus C2 times x minus 3 plus a C3 times 4x minus 1. Set this combination equal to 0 and show that the C1, C2, and C3 are not going to be equal to 0. There will be a combination of them to make this happen. Another way to do this, which is the way that we're going to approach, is going to be to go ahead and try to express the third function as a combination of the first two functions. In other words, I want to take my 4x minus 1 and express it as a combination of C1 times 2x plus 1 plus a C2 times x minus 3. And to do this, we can just multiply everything out. And then we can compare terms and compare powers so that we can see whether or not what matches up. So if we compare the linear or the first power terms, we've got 2c1 plus a c2 equaling out to 4. And then if we compare constants, we've got our c1 right there, yep, c1. And then we've got our minus 3c2, and that must equal out to negative 1. We can now take this system and solve it by either substitution or elimination. Let's go through and solve it using elimination. So I'm going to multiply that second row by, actually, a negative 2. Yeah, why not? So take a negative 2. So that's going to make a negative 2c1 plus a 6c2, and that's equal to a positive 2. That's supposed to be a 6 there. All right, so we add those up, and we get 7c2 is equal to 6. That makes c2 equal to 6/7. And then we know that from the second row that c1 is equal to negative 1 plus 3c2. So c1 is negative 1 plus 18/7. So that's going to be negative 7/7 plus 18/7 makes 11/7. So we can express our 4x minus 1 as the linear combination of 11/7 times the 2x plus 1 plus 6/7 times the second x minus 3. And of course, you can check this out. This is going to be a total of 22/7 plus 6/7 makes 28/7, which is 4 times x. And then 11/7 minus 18/7 is going to be, where did it go? 11/7 minus 18 is going to be negative 7/7, which is a negative 1. So that's our linear combination expressing the third in terms of the first and second.